viewers, welcome to our today's tutorial. So today we will be tackling the introduction to programming, so the tools used in programming, that is computer. So our lesson for today will cover the basic concepts of the tools used to design a program. Those tools are flowcharts, pseudocodes, and also the algorithms that we will. Okay, now as I said of the what we will be doing for today, so flowchart and the pseudocodes, that is the main aim for today. So these are introductions to this. So development of an algorithm, and we said when you read here and you see it is saying an algorithm refers to a limited number of logical steps that a program follows in order to solve a problem. So they are steps written, but they are written steps or logics. So it should follow a logic. So a logic is something that is doable. So and you find in our books mostly it is written. Algorithm refers to English statements. So it is purely English statements, no symbols in it, but English statements. And you see now the pseudocode refers to the statements written in a readable, human readable, our language now, English-like statements. So when you say, so these words are many, but it's upon you now to know the algorithms. These are English statements that one needs to follow to create a flowchart. And also now for a pseudocode, the pseudocode is an English-like statements. So they are English also like statements, and they don't have the symbols or the flow diagram, whatever, but it's English statements. That is the key one. When you use when we are marking and we're seeing that term, that means you are correct. So guidelines for designing a good pseudocode. What must be there? So the statement must be short, clear, and readable. So that is basic. We don't have to use those words that are tricky. So for you to impose for the marker to know that you know a lot of English or you know some terms, but simple statement programming, the elementary topic. So you were taught the tools for programming. For now in your level, there are many, but for now in your level in high school, we only do the three, which the first one is a pseudocode, and a flowchart, and an algorithm. So those three. So pseudocode lines should be clearly outlined and indented clearly. So indentation is key. So indentation, like you see now, while we were writing this one, so you see the chapter, this subtopic here saying guidelines for designing a good pseudocode. When you go downwards here, you find the space. This space that is left from the margin after you have written something, this is called indentation. So when you are drawing a pseudocode, you should indent. If that part is not a part of that block, we call them a block. We will see examples so that you can know what is a block and so on. It should show clearly and state the start and stop, begin, and wherever terms you will use. And also we should have only one exit, like to use maybe, and also begin, end, no matter the term you will use, as long as you are indicating the end of that program. So statements must not have more than one meaning. Ambiguity, you find that there's a term you can use and that term refers to multiple things, so they should be direct and understood. No, I should not be calling a person who has written that flowchart or the pseudocode to guide me on the meanings. Start and stop should be in one line, because from here to here is one block, so this start should be here. So but that well said. So in this question it says write a pseudocode that can be used to prompt the user to enter two numbers, calculate the sum, and average of the two values, the two numbers, and then display the output on the screen. Now there's something called variables, which we were taught. A variable is a temporary memory allocated to capture the data. So it is a memory location in a computer. So when we want to pass an example, like now here we have an x and y. So these x and y's, these are our variables. They will hold data of the values we'll input here. So when you are running, if you write the program, because we say this one is not a program, it will help you to write a program. So when you write your program and there's somewhere now you are told enter two numbers, and you enter, let's say for x you enter 2 and for y you enter 3. So that means what? When you enter that, it means this x has been allocated 2. So that means 2 is the that is the amount that the value 2 is allocated to that. So that's a variable, as we said. So let me not stress much about the variables and so on, because maybe you have been doing them. And we have been told should calculate sum and average of the two numbers. So the basic idea, the print statement is used to display the message on the screen. So this one, even if it is a program, they will be writing the real program, the code. This one, the print statement, will be used to display the message, what the user or the person who is running the program will be able to see. There will be a prompt message saying enter two numbers and the cursor blinking, so that now you can enter one number, either you use a comma or the type of the format of the data. That is the other things. But now x and y, you input the two numbers, the program should do the sum is equals to x plus y average. So this one, and remember, you are not supposed to tell us the calculation. Now you say instead of writing sum is equals to x plus y, you say do the sum of x and y. So there's no directing us. So you should write the formula or an expression to show what is being done there, because now when you write here do the sum, the terms do the sum. So where you should write the formulas, the calculation, those are processes. You write the process so that the programmer can know this is the process that is supposed to be here, and so on. And this is simple, and then output the average after you have divided, because there are two numbers. So let's do introduction to flowchart before we proceed doing now this. We call it the elephant of the room. So we're calling the elephant because now flowcharts have a lot of thinking to compose into the concept of that one. And you know, flowcharts are not that big, but I don't know the mentality around. Maybe after this class, this session, you will be able to draw flowcharts and come up with a flowchart. So flowcharts, what are program flowchart? Because remember, there are different types of flowcharts. We will mention a few here, different. But now a program flowchart is what our area of specifications now. So a flowchart is a diagrammatic representation of a program in algorithms. So what do I mean by saying diagrammatic? Remember, a diagram can have both symbols and text. Or either way you can say, remember for pseudocode, behind there we said a pseudocode English-like statement. So there are no symbols, there are no diagrams. We only use English-like statements to design the algorithm. Now this, for flowcharts, they use a picture representation, a diagrammatic representation of a program. So we are representing the program in a way such that now this program is in a picture form. There are symbols, we will see each symbol and its work, so that now you know a specific symbol is meant to do a specific task. The symbols are of different standard shapes linked to show the order of processing. Each shape contains not stating that what the operation is. So let's continue. So these are the most common flowchart symbols we use in program development. So there's a start and stop. So wherever you want to start and end your program, exit your program, you're supposed to use this. It looks like an oval. The ellipse denotes the beginning and the end of the program. Input stroke output, it's the parallelogram. So this parallelogram denotes the input, where we are saying input X and Y, enter X and Y. We are supposed to, those words, keywords, input, enter, wherever, those words are supposed to be in this symbol. So you cannot draw an ellipse, this oval shape here, and then inside it you write input X and Y. Those words are supposed to be on their symbol. The symbol is there. So and also the output. When you want to print the output, you say print the average, print the sum, output the answer. So the output, generate output, also the same symbol. So when you are doing the input and output, that is the symbol. The process, the rectangle. This rectangle is for process. So indicates that a processing or data transformation is taking place. And which this data transformation, is it sum? We are adding the two numbers. Is it multiplication? So and I said in this, don't say at this stage do the average. Don't write the words do the average. Write the formula for doing that average. You should do it. The rhombus for decisions. So this one either it has two outputs. So either true or false, yes, no matter, but two for which we have an out, and it should be in a question-like format. Question-like format. Is age greater than 10? True, false. Is male or female? Is male? True or false? So if that one is not a male, yes, it is this for false. True or false? It should be in a question. So meaning these ones carry data that are in question-like form. You end with a question mark. These are connected. Remember, we were told in drawing a flowchart, you find that this symbol and when you draw lines, it is like they are crossing each other. We will see some when we are drawing. You find that now we have multiple lines. These flow lines, this one, flow lines, the arrow that indicate the flow of the diagram of the logic. So these ones do not cross each other. Remember, even the guidelines for drawing flowcharts, maybe we will do them here. I will do a sample for this. No, lines are not supposed to cross each other. So when there's a line that is coming to cross each other, in between there we draw a circle, which is a connector, and you don't write the word connector. You can write what is doing. You can write but mostly we leave it. We don't write anything inside the circle. Just draw a circle. We know it is connecting the line and the other line, and so on. So on the arrows are okay. So guidelines for drawing a flowchart: there should be only one entry and one exit, and that we said earlier on. Use correct symbol at each stage, because that is key. We said we don't mix the idea. We only have less symbols. So every symbol has its own work. Avoid crossed lines. So beside the flowchart, do not cross the line. Remember, this question you can be asked in paper 1 theory, and you are asked, give us the guidelines or characteristics of a flowchart, whatever. This is one. There is no crossing of lines. We use a connector to cross, and so on. Be as neat and tidy as possible. General direction of flow of the flowchart is from top to bottom, from right to left to right. So how we go about the flowchart. And remember, also the arrows are key. Make sure the arrows are touching the symbols that are next. So this is an example of a flowchart. So it has a start, and has a stop. So as you're seeing, so this one is saying draw a flowchart for a program used to prompt the user to enter two numbers. The one we did for the pseudocode when we were doing here earlier on pseudocode. So we input two numbers and then we find the average, we display the average. And then remember, we should avoid repetitions. How do repetitions come? So you find here, like now here we are supposed to output, the output is sum. We are saying here, but here now we are saying display the output. So we are supposed to display the output of the sum because we have calculated sum, and also for average. Remember, for the symbol for output is a parallelogram, like now here what we have written here. So because now you cannot say the repetition, now people do tend to repeat this symbol, this parallelogram. When you're drawing a floor line, the arrow to the next symbol, it should not be the parallelogram again. So if again you wanted to output, just write everything, even if it will be a bigger parallelogram, let it be. There's no coming from one symbol to a similar symbol. You are taking it from let's say a process. Now like here, now we have two processes for finding the sum of x and y, and the average here, there was an error bit. It is sum divided by so the idea is simple, as I'm saying. So you are not supposed to, you come here, do this sum, and then direct it to the next flow diagram, which is another circle, another rectangle, and then now you leave sum there, and then again you go to a next symbol, do the average. No, because both of them, they are processes. We have to write them in one process. We avoid repetition. So this is key. Let's see next. So these are types of flowcharts as we dig a deep into the questions. So now a bit now be now comfortable to work questions under flowcharts, because now that is key. Okay, flowcharts are different. So we can find system flowcharts while we are developing systems. So we can draw, we have also their symbols for drawing system flowcharts. So it depicts the systems as a whole with only subsystems or major elements shown. And also this one, we have done it now, the program flowchart shows the sequence of operations as carried out by a computer program. Okay, so control structure. Now this is the idea. Now this is where we were heading to. Program flowcharts. No, the control structures. So these controls are key. When you move from one language to another, when you're doing this one, these are key. You have to understand the control structure. And there are three, there are not many, three. Everywhere you go to any language you're doing, let's say like we did Pascal here. So the Pascal programming language, you go do according in it, you find that you will be using one of these to write your program. Because we said there's a pseudocode or there's a flowchart that will guide you to draw a program. I've been teaching you how to draw, to come up with the programs. And if you missed that one, you can go do more research on the Pascals, and later on maybe I will post some videos on how to come up with a code program. But that one is not necessary because it won't be tested in the exams. But it is good knowing, you know, these things. As you develop the interest is when you will understand this concept. So what are these control structures? These control structures mostly they help the programmer to execute. Remember, it is all about controlling, as the term says, controlling. So what is controlling in basic terms? So controlling, you're directing. So you are telling the program, leave this one, execute this one. Leave this one, execute this one. So that control. So there are blocks of statement that determine how statements are to be executed. They determine how statements are to be executed. like when we said of if statement, or we will go into that one, but now they control. You can also say they control the flow of the execution of statements. Remember we said one line is a statement when we are writing, like this one here, the line here that is written sequence. So this is one statement, this is the next statement saying selection, decision. The third one is iteration, that's a statement. So a statement is one line, one sentence, one line. So because now we can use different, and you will see, like for instance, let's start. So there are three and we have named them. So sequence. So the sequence, in this control structure, the computer reads instructions from a program file starting from the first top line and proceeding downwards one by one to the end. So there's no jumping, there's no control that is telling it jump this one, go. You will see there are others which even when you use iteration, it keeps on looping inside there until it goes to false, so that it can go downwards, it can come up again. You will see that one. So this one here does not have control. It is the program now as it is running, the compiler goes to the first line, second line, downwards until the end. So okay, so an example of this one is when, remember the key term here now, for when we were doing the pseudocode, we said we use the term begin and end. So the program file reads sequentially, statement by statement to the end. So it comes to action 1, reads it, action 2, and so on, and up to the last. When we will be doing more questions, we will be able to understand this concept. So, and there's no much deeper content into the sequential because it does not have many ideas in it. So we don't have the structure like the words we have been hearing of if, nested, repeat until, while, do, and so on. They don't have those ones. So they are purely statements. So it does the that compilation line by line. So there's nothing that is altering the flow downwards. So these are selection. This structure is used to branch depending on whether the condition is true or false, and that is the idea. So we are selecting a portion, like when we said if we have a condition, and we will see, maybe let me not waste time to that one, but let's say if we are using the if statement, there's a keyword again we are supposed to use when we are using a control structure, and there are this selection, because selection is where we have them now, a number, quite a number. You see here the types of selection, there are 4: if then else, nested if, case, selection. So here we have like 4 of them. So in these 4 types, you find that when we are using them, you are supposed to end the number of times they are appearing. Like let's say, like up here for the example here, if the condition here we were testing for a condition like if male is entered, if male, so we said maybe the input, if the input is male, then do this action, else do this one. So this keyword here saying end if. So this end if, it is ending the if control structure. That selection, if we have used if, we end if. So if it is appearing the if, not the else if, because else if is a continuation of the first if. So we should have the continuations downwards. So we will see much into them. So there are 4 in number: if then else. So if then is when we don't have more conditions, or we only have one condition to test and we do it. We don't have anything else to do inside there. So if then else is when we have 2 conditions. So that means we test the first condition, and the next condition we are not supposed to write it. It will be in the else statement, the other else. So when you use if then else, we will see examples. Nested if is when we used if multiple times. So when we have a repetition of if statement, if we are using if to in that condition, that one, and there is a case selection. And remember we have said If we are using a case selection, when we are finishing, we will use end case. If we are using a nested if, the multiple number the if has been used, because nested is mount, so you find that we have used twice the if statement. It means we will have end if repeating twice downwards, because we are ending if for the first if, we are ending if to the, so it will have two end ifs statements, so two statements for end if to end the if control structures. So if then statement is like this one now. So we have a condition, we are testing a mark to reward students who have performed. In this question said this can, for example, if a school wants to reward only the student who have mean mark of 80 and above, it will be reward, or it will be only those students who have, it will reward only those students who have attained 80% and above, and ignore the rest. So mainly we wanted to run this one and at the scores of the students in a school. So those 80 and above, they were to be rewarded. So it should show the term reward to that student. So we say in that idea, because we are not testing many concepts, we are only testing those students who have above 80. So okay, we have come to the end of that part 1. So up to that point, we will continue doing more videos of the same, and also more, the part 2 will be more of the questions, rather than now doing the general formats for the topic, which is the pseudocodes and the flowchart. So hope you watch my part 2 video, so that you can continue knowing and seeing more of the examples I will be doing, so that you can learn from them. And if you have any question concerning the topic, please post on the comment section. So see you in the next video. Bye.